In this lecture, we want the ability to remove items from our box container collection. And let's look at how we could do that. So suppose we have this collection with these elements in from 10 here to the 18 that we have. So our size is going to be probably 11 and our capacity is going to be 13 in this example here. And we want to remove the element 11. So the way we're going to do that, we really have no way of completely remove this slot in an array, because remember, arrays are fixed size collections. So you can't really remove something and have things shrink to take into account how an element was removed. What we can do, however, is override or eclipse this element with a new value. And we don't really care about the order in which elements are stored in our collection here, so we can really put things in any order. What we are going to do, we are going to take the last element and use that to eclipse the current slot containing the elements that we want to remove. So we are going to remove 11 here and store in our 18 to keep it in the collection. And after we do that, we are going to reduce the size of our collection to this point here. And everything outside here is going to be grayed out. This is what we mean. After we do this, we are going to end up with a situation like this. So we have effectively removed the 11 from the collection, and the element that was last has moved in the location where that element was removed from. This is what we achieved here. We can also try and remove the 8 element here, and we are going to do exactly the same thing. We can't really remove the slot here, but we can eclipse it with the current last element. So we are going to take the last element and move that in this slot here, and a copy of that is going to be stored in. So we're no longer going to have in an 8, we will have a 17n, and after that we will change the size of our collection to be from here, and everything after this point is going to be grayed out to mean that it is a free slot that can store elements. After we do this, we are going to end up with a situation like this. And we also want the ability to remove multiple elements that contain the same value. So for example here, if we target the 5s here, we can get this out and this out and this out, and we want this ability. We are going to be removing them one by one, but we will wrap this logic in a function called remove all. And all that function is really going to do is going to remove these things one by one. So if we target the first one here, we can remove it. We're going to take it out. We know that we can't really remove this slot, but we can overshadow it with the last element we have in our array. So we can take the 15 here and store that in this slot. So this is no longer going to be a 5. It is going to be a 15. And we will reduce the size of our array to this location. And anything after this location is going to be grayed out. After we do that, we are going to end up with a situation like this. The first 5 is gone. We have 2 more to go. We will target the second one here, and we want to remove it. We can overshadow it with the last element again. So the 9 here can be copied into this slot. This is no longer going to be a 5. It is going to be a 9. And we will reduce the size of this guy because we just removed one element. So our size is going to be at this location, and anything after this is going to be grayed out. So this guy is going to be grayed out here. And after we do that, we are going to end up with a situation like this. We still have 1 5 left. We can remove it like we have removed the others. So we are going to overshadow it with whatever we have in the last slot. So we can copy this in. This is no longer going to be a 5, it is going to be 18. And anything after this location is going to be grayed out because we are reducing our size up to this point. So this guy is going to be grayed out. And if we take this into account, we are going to end up with a situation like this. This is what we are going to have. And we have effectively removed elements from this collection. So let's look at how we can do this in code. We are going to set up a member function which can remove one item. And we are going to set up an index which is really going to go further in our capacity. This is going to be meaning that the element we want to look for in the collection is not found. Again, this is a large value outside the range of the current array to mean that we didn't really find the element we want. We are going to loop and find the target element that we would want to remove. So if we find it, we're going to store the index where we found it in our index member variable. And we are going to break out of this loop here. I hope you remember the break keyword. It is going to completely freeze the loop and go out at the end of the loop and run whatever is after the loop. So after this, if we found our element, we're going to store its index and we are going to go down here. This is what's going to run. We are going to check and see if the index is actually larger than the size. And if it is, this means that the loop here didn't really find the element we want to look for, and we will just get out because we can't remove an element that isn't in our collection. This is the meaning here. If we fall down here, we will note that our element is in the array and its index is going to be stored in the index variable here. So we can target that element using the syntax here. We are going to overshadow that element with the last element in our array like we saw in the slides. So the last element is at m size -1. So we are going to take the last element and store that in this index. And we are just going to reduce our size by 1 to mean that we just removed one element. This is how we can do this. And we are going to return true. And this return value may be used by whoever called this function to know whether the element was removed or not. Take some moment to really understand this. And if you have a problem, you can ask me. I will do the best I can to help you out. Once we have this method to remove a single element, we can reuse it to set up a method that removes multiple instances of a single element. And this is a trick I used to set this up. I just set up a member variable to store the number of elements we have removed. And after that, I am going to try and remove one element in the collection, which has this value here. If the remove is successful, I am going to increase my remove count to mean that I have removed element and store the count of that in this variable here. And I am going to loop, so I am going to say while removed equals true. And if we remove successfully, we are going to increase our count. And this is going to keep looping as long as we successfully remove an element and return a true value in this removed Boolean value here. And the moment we don't remove an element successfully, we are going to return false. The check here is going to fail and we are going to fall out of this loop and we are going to return the number of elements we have removed. This is how we can achieve the operation of removing multiple elements containing the same value. For example, if we target all these 5, so we can remove them using this member function here. Now that you know this, we're going to head over to Visual Studio Code and see how we can do this in real code. Here we are in our working folder. The current project is removing items and we will be reusing the code from the last lecture. So let's grab everything except for the binary file, of course, and we will copy the code and put this in the current project. And we are going to open this up in Visual Studio Code by dragging and dropping here. This is going to give us our files. We have our box container class and we are going to be building on top of it. And what we want to do is to add public methods to remove items. And we will have 2 versions of this. One is going to be able to remove a single item, which is remove item here. And the other is going to have the ability to remove multiple items containing the same value. And it is called remove all. Let's copy this and put them in our CPP file because we want to put implementations in. So we can go down and put those here. Let's make sure they are aligned properly. And we have to say that they belong to our box container class. Let's do this. And we are going to put in bodies for these to make them valid C++ methods. The remove item method is really simple. It is exactly what we have seen in the slides. And the first thing we do is to find the target item. We are going to loop around trying to find it. If we find it, the location is going to be stored in our index variable here, and we can use that. If we don't find it, index is going to be a really large value, and we can use this to check and see if we actually found it. If the index is larger than our size, we're going to know that we didn't find it, so we have no business removing something that isn't in our collection. This is the logic here. And if we find it, we are going to fall down here, overshadow the target element with the last element by using the statement on line 92 here. So the last element is going to be copied in the element at index, and we are going to reduce our size and really overshadow the current last element and make it a free slot. This is what we can achieve here. And after we remove the element, we are going to return true here to mean that our operation was successful. Now that this method is in place, we can set up a remove all method, which is going to reuse this method repeatedly to remove each single instance of our value here. And the logic is to keep removing a single item until we have no more items containing this value. And we are going to try and remove an element for the first time. If we are successful, the value is going to be stored in our Boolean value here, and we are going to increment our count, and we are going to loop, trying to see if we find an element to remove. And the moment we don't find an element to remove, the call here is going to return false, and the next iteration is going to check and see if removed is true. This is going to fail, and we are going to fall below the loop here, and we are going to return the number of elements we have successfully removed from our collection. This is just my way I came up to do this. I know there may be other ways or even better ways, but this is enough for our purposes. By the way, if you find a new way to do this much better than I did, please do share in the course QA section. I am interested in ways you can come up to really do this in a much better way. Okay, now that we have this in, we can hop over in our main CPP file and actually use this. We can remove everything we have now because we want to see if our methods are working. We are going to set up a box collection. Let's do that, and it is going to be storing elements. I realize this is what we had in, but no problem here. And let's run it and see that we are adding all these elements and see what we have before we start removing stuff. I think this is going to be much easier to follow. So we are going to pass this through our GCC compiler. The build is going to be good. So we are going to bring up a PowerShell window and we can run this. So let's run Rooster. And we are going to add stuff until we have 11 elements with a capacity of 30. After that, we will try to remove items, and I am going to put in the code to do that. So we will say that we are removing items, and we will try to remove 15. We will try to remove 30, which is really not in, and see if this works. And we will try to remove 18 and see what we get. And each time we try to remove something, we will try to print things out. Let's try to build this with our compiler. The build is going to be good as you see here. Let's clear and run Rooster. And now we will try to remove the 15 first, and you're going to see that it is going to go away. 15 is no longer in here, and it was in here. We will try to remove 30, and you're going to see that this is not going to do anything because we don't have 30 in this collection. This is logical. And if we try to remove 18, you are going to see that it is going to go away. 18 is no longer present by the time we hit here. And you are going to see that each time we remove an element, the size is going to go down. We had 11 elements. We remove 1, we have 10. We try to remove 30, we fail. So the size is going to stay 10. And if we remove 18, the size is going to go down to 9. And this is exactly what we expect in this program here. Before we try to remove all, let's make sure we have copies of the same value. So we are going to add 11 and 11. And this is going to be adding up to the 11 we have here. And let's print the data we have in. So we can take this and print this again after we add all this. I think this is going to work just fine. And we can build our program. We're going to pass this through our compiler. The build is going to be good, and we should have a lot of 11s in our collection now. By the end, we have 11. We have another 11 here. We have another 11. This is just what we added in a moment here. So now we can try and remove all instances of 11. The way to do that is really simple. Removing all instances of 11. And all we have to do is say box1 and say remove all. And we're going to say all instances of 11. And after we do this, we're going to print our collection to see that we have actually removed these things. This is what we want to see here. And I think we need to put in an stdcout statement to make this super clear in our output. So let's say removing all instances of 11, and we can put a separator here. This thing we just used for all the other cases, and we can reuse this here to make our output much easier to follow. So this is in. We can build our program and pass this through GCC. The build is going to go through, so we can clear and run rooster, and we want to see that all instances of 11 are gone. You see that we have no more 11s here, and we have removed 3 instances of 11, and our size has gone from 13 to 10. This is what we expect here, and this is really working as we want. This is all I had to share in this lecture, showing you how we can do our remove item methods. We have 2 versions, and we have one to remove a single item, and we have another one that removes multiple instances of a same value, and this is working just right. We are going to stop here in this lecture. In the next one, we're going to see that we can set up a bunch of other operators. For example, the compound add operator, the addition operator, or even the copy assignment operator. And we're going to do all these things. So go ahead and finish up here and meet me there.